Millions of tons of scrap steel, twisted machinery, demolished structures, industrial waste, rusted, bent, forgotten. But inside this massive recycling plant, this scrap is not the end, because in just a few hours, it will be melted, refined, and transformed into the massive steel beams that support modern cities. And it all begins right here. Every day, truckloads of scrap steel arrive from demolition sites, factories, shipyards, and industrial facilities. But not every piece is suitable for structural steel. Different grades, different contamination levels, different compositions. So the first step is sorting. Massive electromagnetic cranes move tons of steel at a time. Workers and automated systems inspect, separate, and classify. Because structural steel demands consistency, and consistency starts here. Some scrap is simply too large to process. Steel beams, machine frames, oversized industrial parts, so it's cut down first. Hydraulic shears slice through thick steel like giant scissors. Then the smaller pieces move into primary shredders. Massive rotating systems tear the steel apart, reducing it into manageable fragments, from chaotic scrap to controlled feedstock. remove lighter materials. Additional sorting systems isolate unwanted metals. Because when steel enters the furnace, purity matters. Even small contamination can affect structural performance.
Check the flow rate on auxiliary lance.
Looks stable. We are ready for the tap.
Now the transformation begins. The prepared steel enters the electric arc furnace. Massive graphite electrodes descend. Electric arcs ignite. Temperatures surge. Beyond 1,600 degrees Celsius, the steel glows, softens, then collapses into molten metal. Sparks explode upward. The furnace roars. This is where scrap loses its old identity and becomes liquid steel.
Check the flow rate on Sector 4. It's holding steady at 25. Temperatures are nominal across the board.
But molten steel is not finished steel. Impurities rise to the surface, forming slag. This slag is removed. Then chemistry takes over. Carbon levels are adjusted, alloying elements may be added, because structural beams require exact composition. Too brittle, failure becomes possible. Too soft, the load becomes dangerous. Precision defines safety.
temperature on line 3 is spiking again.
Rerouting coolant flow now. Monitor the dimension specs closely.
Now the refined steel moves forward. Molten metal flows into continuous casting systems. A flowing river of steel, forming into solid sections. Cooling water stabilizes the outer shell. The interior solidifies as the metal moves forward. Long, semi-finished steel sections emerge, the foundation of construction beams.
The temperature in Zone 3 is dropping too fast. Adjusting the flow rate now. We need to maintain the curve.
Look at this textural inconsistency near the edge. I see it. Logging it as a Class B surface defect. Lower it slowly, watch the alignment. Almost there, bring it down 5 more centimeters.
Before shaping begins, the steel must be reheated. Massive furnaces bring the semi-finished sections back to forming temperature. Red hot, soft enough to reshape, but controlled enough to maintain integrity. Now the real forming begins.
Okay, bring it down slow, watch the gap.
It's flush.
It's flush. All right, hit it with the wrench.
The heated steel enters enormous rolling mills. Massive rollers compress the material, again and again. Each pass reshapes the steel. Flat sections become structural profiles. Flanges emerge. Webs form. The unmistakable geometry of I-beams and H-beams takes shape. This is one of the most powerful transformations in heavy industry. It began as a threat, now becoming the skeleton of skyscrapers. Freshly formed beams are still extremely hot. They move onto cooling beds. Temperature drops under controlled conditions. Then straightening systems correct any distortion, because construction demands precision. A structural beam cannot be even slightly wrong. Now every beam is tested, dimensions are measured, surface integrity is inspected, mechanical properties are verified, load performance is checked. Because these beams won't sit in storage, they'll support bridges, factories, office towers, entire structures. Failure is not an option.